I'm getting really tired. This next one is how many years it's going to take. The keyword in this one is when it says monthly. That means you're going to have to use this equation. And since the question word in here is how many years, right? How many years, we would answer that in like 4 years, 5 years, 20 years, 18 years, 47 years. Something like that. So that means that t is going to be our variable. That's what we're solving for. We should have enough information everywhere else to plug in. But again, you're always reading this question carefully, looking for what the question is asking you for, and then what you have to plug in. I'm given my initial investment of $1,200, which is going to turn into $5,000. Okay, so 1,200 equals 5,000. 1 plus my rate is 7.2% monthly, raised to the n, which is monthly, t is my variable. Okay. So there's my equation. I'll take the glare off a little bit that I'm solving for. To start solving this, I need to work towards getting, and this is a 12. To start solving this, I need to work towards getting this variable term over here all by itself. So first I'm going to divide by 1,200. What I do to one side, I have to do to the other. That's going to allow me to drop these off because I'm doing inverse operations. I'm multiplying by 1,200 and then dividing by 1,200. Those inverse operations undo each other. And then I'm going to my calculator and doing 5,000 divided by 1,200. Beep, boop, bleep. That is 4.16 repeating, or 4.166666666667. And that is equal to, I'm going to simplify this base a little bit. Nope. 0.072 divided by 12 plus 1 is 1.006 raised to the 12t. Okay. At this point, my variable is in the exponent. Since my variable is in the exponent, that means I need to undo it with a log. The only way to get that variable out of the exponent is to undo the exponentiation. Remember, the relationship between logs and exponents is that they're inverse operations. Just like right here, we had times 1,200 divide by 1,200, and they canceled out because they're inverse operations. Here, I'm raising to a power, and so I need to take the log, which undoes that. So you could either do log or natural log. You guys know I prefer natural log because I like the number e. So that's going to be ln of 4.16 repeating equals the ln of 1.006 raised to the 12t. The reason that's helpful is that now over here, because where I have a log, I get to use my log properties, including power property, which brings this whole exponent down in front. So this is now equal to 12t times the ln of 1.006, and my left side stays the same. Trying to get t by itself. T is being multiplied by the ln of 1.006, and t is being multiplied by 12. I erased that 12 a little bit. We undo multiplication with division. So I'm going to divide by 12 ln of 1.006. What I do to one side, I have to do to the other. And just be careful when you're plugging this into your calculator over here, because this is a 1.006. Be careful when you're plugging it into your calculator over here, because that denominator needs parentheses. If you don't put a parentheses, it's not going to get this operation right here correct. So over here, I did my inverse operations to get t by itself. T is equal to this whole, ooh, this is really hard. T is equal to this thing, which when you plug it into your calculator carefully, sorry guys, okay. Now I'm going to do 4.1. 4.166666667 ln of that number divided by, open parentheses, close parentheses. I'm getting that t is approximately 19.88, or about 20 years. Now keep in mind that this is not a very awesome investment. It takes 20 years for $5,000 or for $1,200 to turn into $5,000. And think about how much time has passed in 20 years. This isn't a very great savings account, but it actually earns a lot more than the actual market rate for savings accounts. So that's just some side information.